parametric equations. I suppose I should write so you can see it. So let's take x, y, and t. So this is called a parameter. Officially, it's a characteristic that helps to define or classify a certain system. So we're using it here as time because you're used to x and y to graph like a parabola or an ellipse. Well, here the issue is, let's take, I have an ellipse here. It's not the issue of having an ellipse, it's an issue of where you are at a certain point in time along the ellipse. You're actually moving along it based upon a certain amount of time that's passed. And so it's much more of a, it's not three-dimensional. I guess it is if you look at time as a fourth dimension. Really interesting way you can think about these things. But in this case, it's a different thing than just a regular two-dimensional, just plot the points kind of thing. Though we do that. So we're really looking at the relationship between those three. So what I want to do is take one of these where I'm going to say x is equal to the square root of t, y is equal to t minus 1, and I'm going to give you a limitation that t must be greater than 0. Not a bad limitation, or greater than or equal. Not a bad one because we usually don't have a time that's negative. When you've had equations before, like if you had just one equation, you would just graph it. You do a table, an x-y table, and you pick x's and you plot them for, you figure out what the y's are. We're going to do exactly that, but we're going to do it with a t. So I want you to make a table for me, please, where it's t, where it's x, but x is equal to the square root of t, and y, but y is equal to t minus 1. And then, because t is greater than or equal to 0, I'm going to put in some t's. So I'll start off with 0, because I'm allowed to, it's equal. So I'll figure out the x, so I'll put 0 in here. Square root of 0, there now, that's a little easier to see. I put 0 in here, so x is equal to the square root of 0, x is equal to 0. So that's 0 for the x. When I put 0 in here, I get negative 1. So to plot it on a graph, I need only use these x's and y's, so now I have that. The t's that I put in will give me the x's and y's. So in this case, right now, in a way, we're doing a function of t. That's all, a function based on t. That means 0 and negative 1 is a point that I'll be able to use. Now let's put in 1 second. We'll do this based on seconds. So this is the movement along this graph, where at 0 seconds, you're at this point. At 1 second, put a 1 here, square root of 1 is 1. Put a 1 here, and we're at 0. So now we're at the point 1 and 0. I do not need to put in 2 and deal with square root of 2 or 1.4. What I can do is I can put any point I want. So let's go right to a square root number, and we'll put in 4. I can do decimals. I just really like to keep the nice whole numbers. So I'll put 4 in here for the time. Square root of 4 is 2, so that means the x is 2. When the time is 4 seconds, that means the x has moved to 2, and the y has moved to 3, because if I put 4 in here, I get 3. So I get 2 and 3. Let's do another one to help us with the graphing when we do it. And so the next square root number, perfect square, would be 9. Square root of 9 is 3. Put a 9 in here and I get 8. So square root of, so I put, 3 and 8. Underneath it now, we could keep going, but I don't think we'll need to. Underneath it here, let's do a simple hand graph, but watch what I'm doing is I'm not going far into the negatives because I have very few y's that are negative, and my x's are all positive, so I'm going to focus on here. And I go up to 8. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to use the 8, of course. I'll go down to negative 1. And here I'll go to 1, 2, 3, 4, 5, 6. And actually, that's good enough because I'm going to have to graph it. I graph these points. So simple little graph. graph those points on it. Then we have to talk about what to do next for it. What we're looking at here now is that we have part of a parabola. Because of this limitation, we cannot go to we could go to negative x's if there was a way of getting to them, but we can't get negative x's because we have a square root. We're told specifically we can't use negative t's. So that means this is going to be, we can't go over on this side because then the x's are limited as a result of the t. Okay, so that sort of makes sense. But think about that this is an increase of time. So what's happening here is that I am increasing going this way. So as time goes on, I am actually moving in this direction. I'm just still going that way. Ever since you first learned graphs, you've learned that you could be going this way or you could be going the other way if you wanted to. There's nothing stopping you. There's no reason to go one way or the other. You can go either direction, this way or that way. If you had a straight line, you could go that way or that way. Now, you're only allowed to go in a certain way because the time is increasing. And time doesn't go down, it increases. So that means that you have to put arrows showing the direction you go. So, arrows required. And that's how you graph a parametric equation, or rather in this case a series of parametric equations. So what's going on here is you're given an x and you're given a y. The x and y are in terms of t. So therefore we can use t to get the values we need in order to graph it. But we also use t to determine the direction we're going. So direction is something new for this. So that's, I guess, a reminder for you that that's part of the point of this, is that it's direction-based. Regular parabolas you've done were not direction-based. It doesn't matter, which one you did first. So this is the first major part of the parametric equations part. Is you have to be able to graph them, and you graph them by using those equations, setting up a table, and using t to get ones, graphing it, and putting the arrows. Well, let's go to eliminating the parameter. We're going to set it up so that we get rid of the t. And then you'll see that the graph still ends up the same.